Welcome back to Arxflix. In today's video, we're diving into an exciting paper titled Scaling Up to Excellence: Practicing Model Scaling for Photorealistic Image Restoration in the Wild. This research introduces SUPIR, an innovative image restoration method leveraging generative prior and model scaling to achieve ultra-realistic image restoration. The SUPR model demonstrates impressive restoration capabilities on low-quality images. It can address specific restoration tasks as guided by textual prompts, such as restoring blurry distant objects, defining material textures, and adjusting high-level semantics. As image restoration progresses, expectations for intelligent and perceptual IR results are increasing. Existing approaches leveraging generative priors have made significant strides, yet the potential of model scaling remains untapped. SUPR aims to fill this gap by scaling up IR models to produce high-quality images. SUPIR integrates Stable Diffusion XL (SDXL) with 2.6 billion parameters and a custom adapter with over 600 million parameters, trained on a dataset of 20 million high-resolution images with descriptive text annotations. The SUPR project faced several challenges: scaling engineering constraints, accurately interpreting low-quality images, and preventing uncontrolled generative outputs. The team designed a new connector called Zeroft, fine-tuned the image encoder, and utilized negative quality prompts to improve visual effects. This figure illustrates the SDXL model, trimmed SDXL encoder, and the Zeroft connector. These components work together to leverage large-scale generative priors effectively for image restoration. SUPR's approach includes model scaling, data collection, and diffusion sampling methods. SDXL was chosen over other large-scale generative models due to its direct high-resolution image generation. The degradation-robust encoder is fine-tuned to enhance performance by minimizing the difference between the encoded low-quality and ground-truth images. The large-scale adapter, based on a trimmed version of ControlNet, efficiently guides the restoration process. Additionally, SUPR employs a dataset of high-quality images and textual prompts to guide restoration. The restoration-guided sampling method ensures the output stays faithful to the input image during each diffusion step, balancing low-frequency fidelity and high-frequency details. SUPR was trained on millions of images, including high-quality and negative-quality examples, using a synthetic degradation model. Extensive comparisons show that SUPR excels in both synthetic and real-world scenarios, outperforming state-of-the-art methods. Qualitative comparisons illustrate SUPR's superior performance in restoring textures and details under challenging conditions. SUPR achieves excellent visual fidelity that doesn't always correlate with traditional metrics, suggesting the need for updated evaluation criteria in image restoration. User studies also confirm SUPR's advantage in perceptual quality over other methods. SUPR leverages textual prompts to enable precise control over restoration tasks. This feature allows for guided restoration, enhancing the model's flexibility and applicability in diverse scenarios. Fig. 1 illustrates examples where prompts improve the restoration results significantly. For example, negative quality prompts lead to detailed restorations, and SUPR avoids hallucinating content absent from the original low-quality images. Training on various datasets reveals the importance of large high-quality data for achieving high-fidelity results. The restoration-guided sampling method allows tuning the balance between image fidelity and quality, ensuring optimal restoration outcomes. SUPR represents a transformative leap in the field of image restoration. By scaling up models, innovating training methods, and incorporating textual guidance, SUPR sets a new benchmark for the future of intelligent image restoration. Stay tuned for more exciting developments in deep learning and image processing here on Arxflix. Don't forget to like, subscribe, and hit the bell icon for more updates. See you in the next video. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.